So today I received this Fospower 150 watt power inverter. This is a sponsored review. I received this from the manufacturer to review. I'm not going to give them any breaks. I'm not going to say it's a wonderful product if it's a piece of shit. Pardon my French. But we're going to give it an honest review, as I always do. And we're going to start by opening this up and just take a look at it. And I'll put this thing through its paces. Well, first of all, take a look at it. It's a tiny little unit. Now this is 150 watt. It takes 12 volts DC from your car. In my case, from some batteries. We're going to hook up to a couple batteries. We're going to load this thing down. I'm going to draw 150 watts. I'll put some light bulbs and stuff on here. And we'll see whether we can break this thing. And then we're going to take it apart and take a look at what's inside this thing. So according to the instruction manual, which is written in English, not Chinglish, we'll look at the specifications for this unit. So it'll draw 25 amps to 12 volts DC from your cigarette lighter plug. And you have 3.4 amps DC 5 volts. It's 2 ports shared, so there's 2 USB plugs on the front, so you can charge 2 devices. 3.4 amps combined. It has an output power of peak power of 300 watts, rated power 150, and they do recommend not running it over 120. And it has overload protection at 180 watts, so it should shut down if we overload it. It's going to shut down if the voltage on the battery drops below 9.8 volts, so that's to prevent your battery from being over discharged, so that you can still have some juice left in your car to start your car. We'll look on the other side, and it just has the basic instructions. It's pretty foolproof. You plug it in. There's no power switch or anything on this unit. You plug it into your cigarette lighter and it starts working. Now it's dark, so I can't plug it into my car. We're going to use a couple batteries. I'm going to place a couple batteries in parallel. These are 7 amp hour batteries, or 8 amp hour batteries. So that'll give me 16 amps combined. That should be enough to run this thing. It's going to get some jumpers out here. We'll hook this thing up and we'll load it up and see what it does. Got a couple big incandescent light bulbs we'll hook up on this thing and see how it performs. So just to give my batteries a little more juice here, I've got them on I got a 10 amp battery charger on here as well, because this thing's obviously going to run these batteries down pretty quick if I load it up here. And I just turn on the switch there and it should, there we go. And it started up. I caused a momentary overload there when I first turned it on. This is the 100 watt incandescent bulb here that we've got running. And we're currently drawing about, looks like we're drawing about 9 amps from here, from the power supply. The battery is just obviously, we're using it as a filter, right? So we're drawing about 9 amps here. Light bulb looks good. Let's get a bigger bulb. Okay, I just went and grabbed another light fixture here. This one's got a 60 watt bulb in it. We're going to add a 60 plus the 100. And I think we tripped the over current protection here, but it will come up. There we go. I think we're running out of juice here from my power supply. We're going to be drawing a full 25 amps here, and as you can see, my battery charger here is yeah, I'm drawing more than the 10 amps of my battery charger. These batteries here themselves aren't charged, so they're not going to work. We'll have to try this in the car. Well, there you have it. It's working. I've got a 100 watt. Yes, it's raining too. Can't take the camera any closer because it's raining out right now. I don't want to get the camera wet, but I've got the unit in my car. And I've got a 100 and a 60 watt bulb. They're both running at full brightness. I don't see any fluctuation. This thing is drawing probably close to 20 amps now. at rated power. It's rated 150. I'm running 160 watts on it here. We'll run this thing for a few minutes and see if it gets warm, and then we're going to take it apart and take a look at what this thing looks like inside. Check out the build quality. So far it looks to be pretty stable. It's you know, seems to be working. We'll put the scope on it and take a look at the waveform that it's putting out as well once we get it back into the shop here. Let it run here for maybe about 15-20 minutes and just see how this performs. Okay, so one thing I did notice after running it for about 15 minutes in the car is that when I unplugged it, this tip was slightly warm. It wasn't, I wouldn't call it alarmingly warm, but it was warm to the touch. But we were drawing 150 watts from it. I'm just going to put it back on the batteries here, and I'm only going to run a 60 watt bulb on it this time, just so that I'm not going to run my batteries down too quick. As you can see, when you first turn it on, it takes a second, and then the voltage slowly comes up. So there's no instant surge. It's a gradual start as it comes up, which is good, although some devices may not like that type of a startup. If we turn it off, we turn it back on, you'll see that it is instant on. So one thing to keep in mind, if you're going to be operating devices that don't like a slow start, turn the unit on, wait till the light turns green. Once the light turns green, you should be able to turn on your device. Let's take a look at the waveform on the scope on this really old, ancient scope here. Take a look at what type of waveform we're getting off this thing. Okay, I've just hooked up my ridiculously old scope to this thing, and we'll see what we can see on it. Okay, here's the modified sine wave, but it looks almost more like it's going almost to a square wave here. If we look at the signal, I know it's hard to read on this scope because it's not a very good scope. If I take the load off of it, it probably will. Okay, here we come back. This is what a modified sine wave looks like, which is not really a sine wave at all. What comes off these things is a square wave, and they use some IGBTs to try to create a baseline. So, because typically how these things would operate is they would go from, it would be a square wave with one side reference to ground, and it would just be a square wave signal. And what they try to do is they try to float the neutral and give you a positive and a negative. So basically they do a step. So they modify the duty cycle to average it out for 120 volt. This is under no load, under perfect conditions. When we put a load on here, as you'll see what happens, we really don't have much. It's almost a square wave when we're loading it down with a resistive load. If I put an inductive load on there, we'll see a completely different type of waveform. Let me just put an inductive load on there so we can take a look at it. Let's see how it handles the brute. Let's see what the brute does. Pretty much the same. Okay, waveform's a little bit different, as you can see there. This being 65 watt compact fluorescent. Beauty, huh? It's one of my studio lights here. That sucker is bright. I tell you, that sucker is really bright. So far, everything's looking good. Let's try a TV or something on it and see what happens. Okay, so I've got my sound system, my stereo plugged in here. That's this one here up on the top of the bench here. Let's turn it on and see what happens. Okay, and we'll get some music happening here. It's working. So there's the music playing. As you can see, now this is a conventional. This one's a conventional. Look at the duty cycle when I increase the volume too, right?
De l'avoir d'y avoir poignardé dans le dos finalement parce qu'il a vraiment fait comme pas trop tiens tu voulais. J'aime de l'histoire. C'est cadeau.
So as you can see, the signal, the waveform actually changes slightly, and that's going to depend on the load, right? Keep the voltage regulating good.
L'histoire médiévale.
If I draw more power,
Le millénarisme. Ouais, je suis fascinée par tous les gens maintenant qui parlent de l'an 2000.
Now, if I drive this thing too loud, I'm probably going to put this thing into shutdown because I'm sure that these batteries are probably getting down in voltage pretty quick here. This has got a fairly substantial load. Let's just take a look at our battery voltage and just see how our battery voltage is doing here. So right now I'm running, our batteries are 12.45 volts.
Moi, j'ai trouvé qu'il a bien vieilli. Il a bien vieilli pour ce qu'il est. C'est-à-dire un portrait très situé, très spécifique.
I'm picking the French station just because I'm not going to get nailed for copyright. I don't understand the word they're saying, so.
C'est très réussi comme exercice, mais c'est très situé. Je dis pas ça comme critique là, pour moi.
Okay, so we've shown that the unit works. We've shown the waveform this thing puts out. Let's power this thing down, and let's just take this thing apart and take a look at what's inside this thing. So to break it down, we've got a couple screws in the sides here. Looks like there's this is probably for the heat sink. So we'll take out all these screws. The chassis will probably slide out once I get the screws out of this thing. Uh-oh. I don't know if that was a good one to take out. I hear something rattling inside now. That's already a bad sign. I think I broke it. Don't take the screws out, folks, if you want it to work. I'm sure I'll put it back together. I'll get it back together, no problem. So there's our AC plug. Oh, wires aren't very heavy there, are they? No, it's just that was for the heat sink, by the way. That was a tab that goes inside here and holds the couple of transistors to the base. We'll take the back off it now. The board should actually probably slide out once I get the rest of these screws out here. I'm going to assume that these ones hold the fan in, so I won't take those two out. I'll just take out the 4 on the perimeter here, and that will hopefully allow the board to slide out, and we'll be able to get a look at the circuit board, which it does. You push that through there like that, and there is the unit. Let's take a closer look at this thing. Right here on the input, we'll see that there's a fuse here. So the unit is fused. I was kind of concerned when I first looked into the power plug here. I didn't see a fuse. I didn't sound the alarm bells. Normally you'd expect to see a fuse in here. The fuse is internal, so it does have overcurrent protection, so that if something were to fail on here, it'll blow the fuse. And basically what we've got on this unit here is we've got an inverter. So we've got our oscillator circuit, and it's all surface mounted technology on here. Let's get a good close up of here, get you on camera. Okay, so what we've got here is we've got our input circuit with our filtering. These are going to be our transistors here. These two here are just our oscillator, and basically what they're going to be doing is they're going to be creating a square wave signal at 12 volts. So these are our 12 volt oscillators. It's controlled by our oscillator over, I guess this is probably the oscillator over here. And these are producing a high frequency. It might be lower, it might be 45 kilohertz, because if we look at the little 45 on this thing here, that might give us an indication of what frequency this thing runs at. Looks to be 12 in, 110 volts out. That's our transformer. And that's going to step up the chopped 12 volt supply. And these transistors are just going to be cycling on and off. And they'd be more than likely be 2 phases to it. So basically our 12 volts, if we look on the bottom here, our 12 volts goes in, and goes through the fuse. I'm just trying to trace the circuitry here. And it looks to be that it goes, our ground, looks like this was the ground line here. It's going over to probably our emitters. And then our collectors are going to 2 windings on the transformer, and our power looks to be going to a primary. This is our fuse here. So our power line comes in, this is our DC 12 volts, goes through the fuse. It's going to a winding on the transformer, and the negative side is going, or the ground side is going to the emitters of the output transistors. The collectors are going to 2 separate windings. So basically what this does, when it's oscillating, it's switching one on and then the other. These are switching back and forth. And they're switching back and forth at probably 40 or 50 kilohertz in frequency. The resulting 120 volt output comes out the secondary winding over here on the other side of the transformer, which is on this side. And if you look down onto the board here, you will see that there are rectifier diodes right down in here. So the 120 volts at 40 kilohertz or 50 kilohertz or whatever the frequency is converted back to DC and stored in this little capacitor here. This capacitor is rated, it's a 105 degree cap. What's the rating on this thing here? Let me take a look. It's not going to be very big. It's 22 microfarads at 250 volts. And again, it doesn't have to be very big. It's not storing a lot of power. It's just filtering the ripple on the 45 kilohertz signal, or AC signal, or DC rectified signal through the full wave bridge rectifier. Now we've got 120 or 150 volts. Probably more like 150 or higher, maybe 180 volts DC. Even though it says 110 on here, it's going to float higher than that. The AC conversion is done by these transistors here, and these are, I think they're isolated gate bipolar transistors. I'm pretty sure these are probably IGBTs. Let's see if I can get a number off of these things. I can't see the number, but I'm sure they're going to be IGBTs. We'll look up the number if I can see it. Well, the number on it is an FHP 630, and I can't get any data on it. I searched the number, and it comes up with anything like embedded Bluetooth low energy and NFC combination RF module. Nope, it's not that. I get an image of it, but it doesn't give me any. It doesn't really give me any information on it, at least not in English. And when I go on the data sheets, I haven't been able to find anything on that. Everything wants me to log in and get a quote for parts. So anyway, it's going to be I'm sure it's either a MOSFET or an IGBT, one of the two. Take your pick. But that is what converts the DC signal, the DC voltage coming off of this transformer after it goes through the bridge rectifier. We have our IC controllers down here to generate the pseudo sine wave or modified sine wave signal, and these transistors here conduct to give us the half step and then the full voltage. Anyway, that's basically the unit in a nutshell. Let's take a look at get a close up of the actual soldering, and I apologize because this camera just does not seem to want to focus close like this. My other camera certainly did a better job for the real close-up stuff, but it doesn't look to be too bad, you know. Looking at it with the magnifying glass, I don't see any fault on the quality here of it. All surface mounted components. It's got your USB outputs here, and it would have a regulator down in here for that. Oh, and all it looks like not a bad little unit for what it costs. I guess this is not a bad way to do it if you need 120 volts in your car and you want to charge up a couple devices. If you don't have a USB output in your car, this is an alternative to buying one of those little small USB adapters. This will give you enough power to charge a tablet and a phone, or any USB devices. It also gives you 120 volts, so you can run some bigger chargers, and I think I'll probably make use of this thing for running battery chargers in the car, even though I have a 300 watter already. This one here, I think I could probably make use of this to charge up my laptop and stuff while I'm on the road. Anyway, let's get this thing back together. Of course, you know the hardest part of this is going to be to get that heat sink back on here. I mean, it won't be that difficult because there's a space between the transistors here. I can put the screw in, but I'm going to have to hold this in place. So we have to get a bit ingenious to put this thing back together. And I'm just going to take this heatsink clamp and I'm going to stick it to the back of a screwdriver. See, I'm giving away my trade secrets here. Put the unit back together. Align up the transistors, then I can just slide this thing in the way here. Until I line up the hole. There we go. Fix that now. So now we get the screwdriver back out. Just pull it out like that. As you can see, I've got the heatsink attached. What that does is that squeezes these transistors down to the case. So I'll get this back together and I'll show you guys that it still works. And then that will close off this video. Okay, unit's back together. Unit is on. We have got my stereo going through, okay? Can't leave that running, but hey, we're back together. Unit's working. It does do what they say. It does provide 150 watts continuous. I ran it at 160 for about 20 minutes. The unit didn't even get warm. The fan was running. I knew the air was slightly warm coming out of the back, but it wasn't getting hot. I did notice that the center pin here on the DC input was a bit warm. Not hot, but warm. And which is to be expected because it was drawing, probably close to 20 amps when it was running there. The unit, it does what it says. It works. The only thing I can fault is the non-installation of the cases of the inverter transistors for the AC sine wave or modified sine wave generation. The only thing I haven't checked on this yet is the USB. So let's plug a phone in and see if it charges. So I've got my ancient phone here. We'll plug it in and we'll see how it charges. This one has like a 1.5 amp charger for it. So give this thing a minute and see if it will turn on. This phone is completely dead. So we'll give this thing a minute here and see whether it'll actually fire up off of this unit. It'll give us an idea how much power. Oh, it's starting up already. We'll let it boot up here and see how it's charging. There, as you can see, it's charging up no problem. You can see the little charge indicators flashing here. So the unit has more than enough current to charge up a phone. I can do 2 devices at once, and you've got the 120 volt output on it. Thanks for watching. We'll catch you in the next one. If you like this channel, please consider supporting me on Patreon.